Okay, we were on chapter 11.4 and we're on the last little part. We've done example 3 before. We're going to do example 4. So your little subheading is the length of a tangent to a circle from a given point. So you're looking for the length of a tangent. It's actually quite simple. We're looking for the length of this line. We'll be able to know the length of that line because that's the radius of the circle. We'll be able to find out the length of this, and we're only going to use Pythagoras. That's all the yellow box is there. So we'll do example 4, then I'll get you to try a couple of questions, and after this we'll probably do a bit more in these videos and get you to do a tiny bit more. Okay, so the first thing we're going to do is we're going to do a sketch. So take down the question, find the length of the tangent from minus 5/8 to this circle. Okay, so what we can do is we can do a little sketch. So we have a circle. Okay, the center there. We know the center of this circle is 2, 3. Half of this change the sign, half of this change the sign. We've done that at the start of this chapter. We also know this point minus 5/8. If this is 2, 3, minus 5/8 is definitely down here and it's up here somewhere. Okay, so just say this is minus 5/8. We want the length of the tangent from this point to this circle. So what we do is we draw a triangle. We know that this is a perpendicular distance because the point that a circle meets a tangent to the center, that is a right angle. And then if we just complete the triangle by doing something, joining those 2 points. What we're looking for is this length here, from here to here. Call it x. We know we can find this length here. This is the radius. And we find the radius using the formula that's given to us in our maths tables. The radius is equal to the square root of g squared plus f squared minus c. And again, I think Abdu said it doesn't matter we use positive or negative, it's just because when you square it, it doesn't matter. So 2 squared plus 3 squared and then minus 3 because c is 3. 4 plus 9 minus 3, that works out as the square root of 10. So we now know that this is the square root of 10. We can now also find out this length here because that's the distance between 2 points. So if we label this x1, y1 and this x2, y2, go to our maths tables and write out our distance formula. Distance formula is x2 minus x1 squared plus y2 minus y1 squared. And it's the square root of that. So I just run out a bit of space there. So we fill that in. Distance is equal to the square root of x2 is 2 minus 5 squared plus y2 is 3 minus 8 squared. That's equal to, that's going to become a plus, so it's going to be 7 squared is 49, minus 5 squared is plus 25, so that is equal to the square root of 74. So we now know that this length here is the square root of 74. And what we're asking the question is, what's the length of this line here? From this point to the circle, what's the length of the tangent? And this is a right angle triangle, so we just use Pythagoras. Okay, so if we just slide this up here, 1 sec. We now have a triangle that looks like this. This is a right angle. This is square root 10. This is square root 74. And we're looking for x. So it's simply Pythagoras. And we're not looking for the longer side, we're looking for one of the shorter sides. So it's minus 74, sorry, square root 74 squared minus square root 10 squared equals x squared. So x squared is equal to 74 minus 10. X squared is equal to 64. So x is equal to plus or minus 8, but it's 8 because it's a length. So the length is 8. Alright, so if you take down that example underneath the subheading number 4, and then I'll get you to try a couple of questions. Okay. Any questions, please comment.